This represents the first focus lesson for Chapter 5, Section 5. I hope you have your textbooks open to page 326 and that you have some paper to write down the numbers as we work on them to kind of see what's going on. The first question we're going to look at today is number 9, which has x minus 2y equals 2, and it's asking us for the x and y intercepts of the graph of each equation. Being that we might be new to this, we're going to use the book, and the book is referring us to problem 1, so let's look back at problem 1 and see exactly what this is doing. It's saying, what are the x and y intercepts of the graph 3x plus 4y equals 24? Step 1, it says to find the x-intercept, substitute 0 for y, and then solve for x. So x-intercept means put in y equals 0. And so what they do is they go back to the original formula. They turn y into a 0, which 4 times 0 becomes 0. So for the most part, it makes this go away, leaving us with 3x equals 24. I believe at this point they simply divide both sides by 3 to get x equals 8. So your x-intercept is 8. It says step 2, to find the y-intercept, substitute 0 for x. So I guess your hint here is for your y-intercept, we need to put in x equals 0. Looks like you're just using the opposite letter. So if I want the x-intercept, plug in 0 for y, make y go away. If I want the y-intercept, plug in 0 for x, make x go away. So let's see what happened. 3 again, or x turned into a 0. 3 times 0, of course, was 0, which meant it just kind of disappeared. And then 4y equals 24 came down. Dividing by 4, now you end up with y equals 6. And I think we should have at least a decent idea on what's going on back here on number 9. So number 9, it wants the x and y intercept. So what I will do is I will put down y-intercept first. And I'll remember that y-intercept means I need to put 0 in for the opposite letter, which means instead of x minus 2y equals 2, I will put 0 minus 2y equals 2. And then solve it using algebra. Because that's a 0, this goes away. But notice how the negative stays there, so this ends up being negative 2y equals 2. Whenever I solve and there's a negative, I just switch signs on both sides. So I'd switch to make this the opposite of what it is, which of course makes this the opposite of what it is. And then I divide both sides by 2, getting y equals negative 1. So that is my y-intercept. When I want my x-intercept, I again remember that in order to find the x-intercept, I plug in 0 for the opposite letter, so I end up with x minus 2 times 0, because that's y now, equals 2. I remember that anytime you take something times 0, it turns into 0 and pretty much just goes away. And the only thing that comes down now is x equals 2. And because that's already simplified, that is my x-intercept. Very simple process. Just make sure that you practice it to make sure you know which one goes where. Notice the y-intercept ends off with the y. Notice x-intercept ends off with an x. So if you're looking for a y-intercept and you get an x, it means you probably did it backwards. But just make sure you think through that whenever you do it. Number 11 has 3x minus 5y equals negative 20. And they want the x and y intercept. So again, the first thing I'm going to do is my y-intercept. And remember again that y-intercept means I want x to go away, or I want 0 to go in for x. And so what I do now is I plug in 3 times 0 minus 5y equals negative 20, being careful with my signs. 3 times 0 means that this is going to disappear because it's going to turn into 0. Again, being careful about your sign. You can divide by negative 5 if you want, but what I usually do again is I switch signs on both sides, so I'm careful making that positive, and because this is negative, it makes that positive. Then I divide both sides by whatever is attached to the variable, and I find out that my y-intercept is y equals 4. I then go over and do my x-intercept. Again, x-intercept means I put 0 in for y, and so I will rewrite everything else from the original equation except I'll put 0 in for y. I will then recognize that this 5 times 0 ends up going away, leaving me with 3x equals negative 20. I then divide both sides by 3, and I guess you got a couple options you can do here. And for the sake of this, what you can do is you can leave it as negative 20 over 3, because that's reduced as far as it can be, or you can turn that into a decimal if you'd like. So 20 divided by 3, which is about 6.67. And remember to be negative. Or if you know how to turn this into a mixed number, which is that 3 goes into 20 6 times, so it would be negative 6. 6 times 3 is 18, so there would be 2 left over, and it would be exactly 6 2/3 or negative 6 2/3. Either one of those works. Just make sure you have some way to know and understand what this means. I would say either turn into a mixed number or turn into a decimal. That way we can actually approximate where the x-intercept is. The next thing we're going to do is look at a question that wants us to draw a line with the given intercepts. Number 15 says draw a line with the given intercepts. The x-intercept is -1 and the y-intercept is -4. Now this here says graphing a line using intercepts, which is problem 2. Looks to me like once they find the x-intercept of -2, they simply went to where x is -2. Remember, this is the x-axis, so that's the x-intercept, and so they went back to 2 and put a dot. Once they found the y-intercept to be 1, they went up to where y was 1. So this here, I don't even really have to do anything but just make sure I know what the intercepts are. So I'll draw my axis. Nothing major. Again, remember that this is my x-intercept or x-axis. -1 is backwards 1, which would be here. So that would be my first spot. And then -4 would be down 4. Again, the positive numbers go up for y. So 1, 2, 3, 4. And then, yes, you would want to use a straight edge, but for right now we don't have one. And your line will look something like this. And that is the main thing you're going to do. Check out number 19. It doesn't give me the intercepts, but remember what we just did. It means that we know how to find the intercept. So what we will do now is we'll find our y-intercept by plugging in x equals 0. We get 0 minus y equals -8. Again, 0 disappears, leaving -y equals -8, which means that we switch that around to get y equals 8. That's one number we're going to look for. And then when we go to find our x-intercept, it means we put 0 in for y, so x minus 0 equals -8. Again, the 0 goes away. The only thing that comes down is x equals -8, which is my x-intercept. And now I can graph it the way I'm supposed to. Y equals 8 means it's on the y-axis, so 1, 2, 3, 4, 5, 6, 7, 8. And then x equals -8 would be backwards 1, 2, 3, 4, 5, 6, 7, 8. It's not going to be perfect whenever you draw it kind of freehand, but as long as you've got the right idea. Remember, this is mainly a review for you right now, and that should get you about where you need to be. And then 21 has -4x plus y equals -12. Again, it doesn't give me either one of the intercepts, so I have to find it. So I'll do y-intercept first. That means plug in 0 for x, so -4 times 0 plus y equals -12. This goes away, leaving me just y equals -12, which is my first intercept. Then I have to find the second one. X-intercept means plug 0 in for y, so 4x plus 0 equals -12. Getting rid of that plus 0 means that all we have now left is -4x equals -12. Again, whenever I have a negative, I just kind of flip both sides. So this turns into positive 4x, which of course makes this a positive 12. Dividing both sides by 4, we end up with x equals 3. And so graphing this, x equals 3 would be the positive direction. Again, this is my x-intercept or x-axis, so 1, 2, 3 would be about right there. And y equals -12 would of course be down 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And again, draw the best line you can all the way across the region that goes through both of those points. Make sure you know how to find your intercepts. Make sure you know how to use them and apply them on your graph, and that represents again the first part of your focus lesson. Be sure you're asking questions and doing what you need to do there.